All right, welcome to the Explainer. Today we're cracking the code on SQL. We're going to cover the absolute must-know concepts that will help you ace that next technical interview or really just master the language that powers pretty much everything on the web. So what do these giants have in common? Well, behind all those slick apps and crazy powerful algorithms, they all depend on one single technology to wrangle the insane amounts of data they deal with every single day. And yep, you guessed it, that's SQL. And look, this isn't just a thing for data scientists anymore. Are you a Python dev, a web developer, a data analyst, heck, even a software tester? If you're touching data in any way, shape, or form, SQL is the language you use to talk to it. It's the universal translator, and you better believe interviewers know that. All right, let's jump right in. We're going to start with the absolute basics, the foundation of how data is even organized in the first place. You got to know this stuff because everything else is built on top of it. So what's the big deal here? It all comes down to that letter R for relational. You see, a basic DBMS is like having a bunch of separate Word docs for student info. One for names, one for addresses, one for grades. Finding anything is a total nightmare. But in our DBMS, that's relational. It creates these smart logical links between all that info, and that's a game changer because it cuts down on repeated data and makes finding what you need super, super fast. Okay, primary key. Why do interviewers care so much about this? Because it's all about data integrity. I mean, think about it. Without a primary key, you could have two rows that are completely identical. How would the database tell them apart? It couldn't. The primary key is that one unique ID, like a student's roll number, that guarantees you're looking at one and only one specific record. And yeah, it can never be empty. Ever. And this is how we make those relations we were just talking about. So if that student's roll number is the primary key in the student table, we can just pop that same number into a different table, say for courses. Now in that courses table, it's a foreign key. It's like a bridge connecting the two, telling us exactly which courses that specific student is taking. Pretty clever, right? Okay, so we've got our structure. We know how the tables are related. Now let's talk about the rules we can set and the actual commands we use to boss the database around. You know, the easiest way to think about these constraints is to picture a Google form. When you make the email field required, that's not null. When you make sure no two people can use the same username, that's unique. You could even add a rule, a check, to make sure someone's age is over 18. These are just rules to make sure the data you're getting is clean and usable right from the get-go. This one's another classic interview question, DDL versus DML. Here's the deal. DDL commands, like create or alter, are like the architect's blueprints. They build the house, the skeleton of your database. DML commands, like insert or update, well, that's you moving the furniture in. It's the stuff that goes inside the structure. DDL builds it, DML fills it. And when it comes to getting rid of data, this bookshelf analogy is perfect. Delete is like carefully picking one specific book off the shelf. Truncate? That's like swiping your arm across the whole shelf and knocking everything off at once. It's fast, but the shelf is still there. And drop? Well, drop is taking a sledgehammer to the bookshelf itself. The shelf, the books, everything gone for good. Okay, so our database is built, we know how to manage it, and it's packed with data. Now for the fun part. It's time to do what SQL was born to do. Ask it questions and uncover some cool insights. Group by versus order by. People get tripped up by this all the time, but it's actually pretty simple. Just ask yourself, what am I trying to do? Am I trying to summarize my data? Then you want group by. It literally puts your data into buckets, like grouping employees by department so you can find the average salary for each one. But if you just want to sort your data, like listing every single employee from the highest salary to the lowest, that's order by. So remember, group by summarizes, order by sorts. That's it. And here's another classic duo. Just remember this little story. Where is like the watchman at the gate of a party. He checks every single person, every single row, before they're allowed inside. Having, on the other hand, is like the judge at the end of a talent show. He doesn't look at individuals, he looks at the groups already on stage and decides which ones make the cut. So one more time. Where filters rows, having filters groups. Now, these 5 functions, these are the heavy lifters of data analysis, for real. With just one simple command, you can take millions of rows of data and boil them down to a single powerful number. How many employees do we have? What's our total payroll? What's the average salary? You can find all that out instantly. They are absolutely essential.
Look, getting the basics right is awesome, but if you really want to impress an interviewer, you need to show them you're thinking about performance, about efficiency, about building things the smart way. That's what separates the good candidates from the great ones.
Indexing is so important for performance. Just imagine someone hands you a 500-page textbook and says, find the section on quantum physics. But wait, there's no index in the back. You'd have to read every single page, right? That's what your database does without an index. It's called a full table scan, and it's slow. An index is, well, it's the index in the back of the book. It tells the database exactly where to go, turning a painfully slow search into a lightning-fast lookup.
Okay, normalization. That word sounds super academic and intimidating, right? But honestly, it's just a fancy term for organizing your database smartly. The whole point is to get rid of duplicate data and stop errors from happening. You just follow the steps. First, normal form. Make sure every little box, every cell has just one value. Then you move on, cleaning things up, making sure data depends on the right things. Each step just makes your database more solid and reliable.
All right, we're in the home stretch. Let's talk about the pro-tier stuff. If you can nail these next few concepts, you're signaling to an interviewer that you don't just know the commands, you actually understand how SQL really works.
I love this analogy. Union is like making the final guest list for a party. You take your list of school friends and your list of work friends and you combine them, but you cross off any duplicate names, right? Union All is the full roster. It just combines both lists, and if someone's name is on there twice, so be it. And because it doesn't bother checking for duplicates, Union All is actually a lot faster.
Views are so useful for keeping things simple and secure. The best way to think of a view is like a saved, secure window that looks into your real data. It doesn't actually hold any data itself. It just shows you a specific slice of the real tables that you predefined. It's perfect for when you need to give someone access to only certain columns and rows without letting them see the whole shebang. Triggers are basically the if this, then that for your database. They're these little automated scripts that just run whenever a specific thing happens. So think about a library. Instead of a person having to manually update a spreadsheet every time a book is checked out, you could have a trigger that automatically lowers the books_in-stock number the second that checkout happens. It cuts down on human error and saves a ton of boring work. And here we are, the big one, the classic find the second highest salary problem. Now, this question isn't really about knowing a specific command. It's a test to see if you can think in layers. And that's exactly how you solve it, with nested queries. First, deep inside, you find the absolute highest salary. Easy enough. Then, in the query wrapped around that, you find the highest salary that is less than that first result. And boom, by definition, that's your second highest salary. Then you just use that number to find the employee. And that's a wrap. We've covered the foundations, the core commands, and even some of the pro-level stuff. So I'll just leave you with this final thought. At the end of the day, getting good at SQL isn't really about passing an interview. It's about giving yourself the power to ask your own questions to the data that is literally running our world.